Hello everyone, welcome to this lecture on CFX expression language. This lecture is part of the Learn CAX course on CFD modeling using ANSYS CFX. The expression language is used to create our own variable expressions and use them as plotting or reporting variables at different locations in CFD post. First, let us see what is CFX expression language used for. The CFX expression language allows the user to create equations which can be function of solution or system variables. These equations can be used in CFX pre and CFX and CFD post. An example here is the absolute value of exponential function shown. We will see in this session how to create these expressions. So what is shown here is this absolute exponential function which is created by using the expressions language, and it is plotted as a function of time. There are certain rules by which there are certain rules of the CFX expression language. Let us list them one by one here. There are certain rules which need to be followed in order to create CFX expression languages. Let us list them here. The syntax rules are same as those for conventional arithmetic. Operations that are written as or allowed. Operations that are allowed are addition, subtraction, multiplication, division, and exponential. Variables and expressions are case sensitive, which means small t is different compared to capital T. Capital T stands for temperature, small t stands for time. So it is not case independent. The expression language is case sensitive. Expressions must be dimensionally consistent for addition and subtraction operations. So the units must be same if we want to add or subtract any variables. Fractional and decimal powers are allowed in the language, so you can use fractional and decimal expressions. Units of expressions are not declared. They are results of the units in the expression. So expression will not have a unit. Whatever expression you have written, the resultant units will be assigned to the expression. Some constants are readily available for use. The E constant is available, its value is directly available. You can directly use E. You can use G, that is acceleration due to gravity. Pi is a constant that is available, and universal gas constant is also available. Now there are some built-in functions also. You don't have to write from scratch any function. There are lots of built-in functions that are available. The list is here given. Custom functions with user Fortran can also be created. So the standard functions that are available is sine function, the cos function, tan function, the a sine, the a cos and a tan function, exponential function, log function, logarithmic function, the absolute function, square root, minimum maximum values. These are all standard functions that are available. So you can use them as it is. You just have to change the variable inside it, that is x, and input any variable in place of that. The dimensions are there for all the functions. So for sine, cos and tan, angle dimension is fixed. The a sine, a cos is dimensionless. Absolute function can have any dimension. So you can use different types of ready-made functions here. System variables are available for use in any expression. Units can be included as well. We will review a list of system variables here. So the first system variable is x, which is direction 1 in the reference coordinate system. Next is y, which is direction 2 in the reference coordinate system. Z, which is direction 3 in the reference coordinate system. R is a system variable which is the radial spatial location. Theta is the angular location. T, small t is time. U is the x velocity. V is the y velocity, and W is the z velocity component. P is absolute pressure. Ke is kinetic energy, turbulent kinetic energy. Ed is turbulent eddy dissipation. Capital T is temperature. Shear strain rate is also available as a system variable. Density is there. Then there is non-dimensional radius, that is r, no dimension. Viscosity is available. Cp is available. Conductivity is available, and it is and mass fraction, that is Mf, is another variable that is available. So these are all system variables which can be directly used, and their value will be taken from the results. Let us see how to create a CFX expression language or an expression using the CFX expression language. First, we have to go to expressions here as shown. Then we click on insert, expression. After this, the expressions dialog box opens up. We have to give the name of the expression and then start writing the expression here in the definition. So you can write any expression that you want here and then press apply so that the expression is created. how to select variables in the expression. In the definition, you have to go on creating expressions. So for that, you also have to select variable. Click on the expression definition dialog box and right click the mouse. After you right click the mouse, a pop-up menu will appear which will have functions, expression, variable, mesh locators, physics locator, constant. So when you go to variables, a list of all system variables are available. You can select any of this and insert it in the expression. You can also go to functions and select location based functions like area, area average, count, force, mass, mass average. Best thing to do is go to expression definition dialog box, right click, and you have functions, expressions, variables, and go on inserting and create your function using lots of entities that are available in this. So one by one we will see what all functions are there. We have the locator based functions, which is like depending upon location you can take different averages like area average, area integral, count, force, mass average. Then there is also CFX expression language functions, which are absolute functions, cost functions, sine functions, logarithmic functions. Then we have constants, like the standard constants that are available, like the Avogadro's number, Boltzmann constant, gravitational acceleration. All these values, readily available values, are under constant section. We can also select mesh locators, which is like which are the surfaces that you want to plot on. So you can also include surface. If you want to take volume average on a 2D surface, you can if you want to take volume average across a volume, you can input that. And physics locators means what all locations, boundary conditions that are defined, they also appear in the physics locators. So these are mesh locators and these are physics locators. So let us study this entire process using an example. What we have to do is we have to create variable viscosity of a shear thickening fluid. So the expression is defined by this particular equation. You have to input this equation as a CFX expression language function or expression. Here gamma is the shear strain rate. System variable is accessed with right mouse click button. So we go to the expressions, insert expression, name it as non-Newton viscosity. Then we input it as K into shear strain rate raised to n-1. So shear strain rate is directly available as a ready-made function when we right click on the system variables. So when we right click, select system variable shear strain rate, we define this function, we input n-1 K, and then we have a plot of system variable here. So when we say we want to actually assign this, we can plot this, and we can also assign this as a dynamic viscosity in the materials panel. So we can plot as well as use this in the simulation. For using this in the simulation, we can go to the materials properties, and instead of dynamic viscosity single value, we can input this expression, which will now change with shear strain rate for non-Newtonian viscosity. So in this way, we have defined a non-Newtonian viscosity. We can also directly input this expression as shown. We can click here and input this expression right into the dynamic viscosity section. So we don't have to write it in the expression itself, expression panel itself. We can also write an expression in the dialog box also, which means in the material section itself, we can click on expression, write our expression there itself, or define our expression there itself. It gets automatically defined. We don't have to go to the expression, insert expression option.